Hi, my name is Stefan and I'm on a mission to show that 3D animation or animation can be a valuable tool in the classroom of today. It can be a tool for teachers to grab the learner's attention by doing something really funky and modern. And also, if you get learners interested in 3D animation, who knows, there are possible career paths in the future. I'm going to animate a bouncing ball quickly and show how time and distance can be clearly shown on the screen and can be a big discussion point in the classroom. So I'm going to add a UV sphere and I'm going to make this a ball that bounces. Now I'm going to use the x-axis in this view, that's the red line. I'm going to use that as the ground. So I'm going to lock this ball in place on there, and then I've got frames marked out. We're working at 25 frames per second. Over here, that means that every second 25 frames or pictures will pass. So I'm going to take this ball and at frame 10 I'm going to place it on the ground. Then at frame 17 it'll be at the top of the next arc of the bounce, and at frame 24 it'll touch ground again. Frame 28 it'll be up in the air, top of the arc, and frame 32 it'll stop on the ground. Now I'm going to make it stop dead. It's not natural, but it's good enough for this explanation. So what we can see here, you can immediately see that the consecutive bounces take less time, and that you can see from those keyframes that I added there. Now this blue line, this blue graph, is the z-axis. That's the height of the ball, and this is time. So we've got distance over time. If you look at this animation now, you'll see that it doesn't look natural. Right? The ball kind of drifts, right? So that's because this graph is incorrect. We've got the ball coming down, and as it falls there, it should gather speed, it should pick up speed. So it should cover more distance in a shorter period of time. So I'm going to just change this so that I can make it like this, which will mean over this time period there, it only covered that bit of distance. But almost in the same length of time here, the second half of this drop, it covers that amount of distance, right? So it's moving quicker towards the end. And then when it leaves the ground, again, it should be at a higher speed. Same reasoning. And on this side here, let's switch that as well. So we change the speed by changing the graph. So we've got, now when we look at the animation, let's have a look at that. And you see now it looks like it's bouncing. And we did that simply by changing the graph in the animation and making the time-distance relationship more realistic. If you're interested, there's a course starting in 3D animation on blenderschool.com. Go check it out, register for free for the pre-course videos, and if you're interested, enroll for the course. The software is free, you don't have to buy the software, it's open source. The course is not free, but this is such an awesome skill that you can take into your future as a teacher and awe your students with your ability and grab their attention. Cheers.